You might not realize it, but we are exposed to dozens of hazards every day. Can any of these hazards negatively impact your health? Definitely. This is the Exposure Scientist Podcast. My name is Alex LeBeau, and here we answer your questions and concerns on what you may be exposed to every day. Welcome to the Exposure Scientist Podcast. Hello, and welcome to today's episode of the Exposure Scientist Podcast. This is the first episode of 2026. I hope everyone is having a great new year. It's been off to a very fast start for me, and hopefully everyone's is going well for yourselves. My name is Alex LeBeau, as I said in the introduction. It's been a little while. We have a number of seasoned individuals that listen to the podcast. This is our third year doing the podcast, so we have a number of subscribers, but we also have a number of new individuals as well subscribing to the podcast. So I'd like to tell you a little bit about myself. Again, my name is Alex LeBeau. I'm an exposure scientist, which means I evaluate exposures to chemicals and biological organisms. I understand the exposure scenario. I evaluate the exposure scenario, and then I look at the exposure and determine how the exposure can translate into an internalized amount into the body, which we call a dose. From that evaluation of exposure and dose, I evaluate risk. That's what I do all day, every day for a number of different individuals that approach me and say, hey, can you help with our exposure scenario? Or, hey, can you help us understand risk based on this exposure scenario and all these different parameters? That's what I do. That's what I've done for going on almost 18 years now. So as part of the normal process of what I do, I pay attention to, the news. Again, I do this from the exposure scientist toxicologist side. I have done product safety assessments. I've done what we call GRAS, generally recognized as safe determinations for food ingredients. What caught my attention today was a news article, some publications going out there, and some information from the state of Florida on some data for candy. And I will fully admit that I unfortunately have a sweet tooth. I do my best to control it, but everyone I think has some vice, and being enjoying sweets is sometimes mine. But I digress. What caught my eye was this information, and I'll tell you the website. I have no problem doing that. It's called exposingfoodtoxins.com. It's the title of it says Healthy Florida First, Building a Healthier Florida Together. And there's information on there on two things, and I'm going to focus on one of them. One is baby formula toxins, and the other is candy toxins. And this caught my eye. And the news articles that I was seeing and information and stories were relating to arsenic identified in a number of different candies, and the state of Florida put this information out there. And I thought it was intriguing when I started looking at the information and identifying why there's not a complete story being told here. And it leaves lots of what we in this as scientists call data gaps or questions on what this data even means. So very quickly, because not to bore everyone, but generally, what is arsenic? Arsenic, I'll just give you some, I'll say dry data or information. Arsenic is the 20th most abundant element contained within the Earth's crust. You look at the periodic table, you can see where arsenic is. It's a very common element. Arsenic exists in a number of different forms. Generally, we divide that up into what we call organic arsenic and inorganic arsenic. And the most, I'll say, more hazardous form of that is the inorganic form. And when we talk about hazards, there's a whole discussion of hazard versus risk. I've done podcasts on this before, but hazard is identifying something that can cause harm. Risk is the probability of it causing harm. So arsenic as an inorganic form is a more hazardous form than organic. And even within the inorganic form of arsenic, there are different formulations of that. There are what we call trivalent and pentavalent arsenic, as it's found. The trivalent form is the more hazardous of those two forms. It's more toxic, I'll say. So, what has arsenic been used for before? Again, arsenic is a naturally occurring element in the earth. It's been used before as a coloring agent. Arsenic is used as a hardening agent for metals. It can be a catalyst for chemical or reactions. It's used also in textiles and wood preservatives as well. But again, there's more things that it's used for. These are general ideas, but lots of other chemicals and constituents are used for also other different things. So arsenic is not unique in the form that this is the only thing that can do these processes. Other constituents or other chemicals or other elements can do this as well. So these are just some things that are arsenic is known for. So how abundant is arsenic? Well, it's so abundant that there are levels that are established for drinking water standards. EPA has put out what we call a maximum contaminant level of 10 part per billion of arsenic. If you look at your local water quality reports, you can go on there and they typically, if they're a large water utility, they'll say arsenic, and we evaluated arsenic, or the local water utility tested for arsenic, and these are the levels. This is the range that was found. This is the average level of arsenic that was found. Arsenic is not uncommon. I just want everyone to understand that. There is always going to be some detectable level at some point. But going back to the state of Florida's information, so there's a lot of information here that says arsenic is found at, I'll say, what they have identified as high levels. It's in red. I'm not going to name the candy. You can go on there and look at it yourself. But of the ones that I'm looking at now, and I'm looking at the website, the highest level of arsenic in any one particular food item here, one particular candy, looks to be 510 parts per billion. That seems high. And along that 510 parts per billion, the state of Florida has done some kind of risk assessment. So let me general. So they've done this risk assessment for children and adults, and said, these are the amount of pieces that you can safely consume per year. There's a lot of information here that is missing. So let me tell you what I typically do when I am performing a human health risk assessment, whether it's a product safety assessment, it's a food assessment, or an exposure scenario. What do I do when someone comes to me and says, I have this chemical, this was the exposure. What am I gonna get sick? Because that's what it ultimately comes down to, is what is the risk that someone can develop an adverse health outcome from exposure to a particular constituent? Here, it's going to be arsenic. Generally, what I do, I'll start this off. Again, going back to the hazard versus risk scenario. From a human health risk assessment standpoint, I say, well, is this constituent identified as a hazard? Are the data supportive that this is a human health hazard? Hazard is something that could cause a adverse health effect at some level. Who knows what the level is, but data shows that it could cause a level. Sure. Okay. Yes. Arsenic does that. We have data that supports that. Okay. Now what do? We understand the risk, the exposure scenario. What were the individuals exposed to? There are calculations out there for you to understand what the exposures were, to understand historical exposures. There are inputs that can be used. There are generally what we would refer to as general or standard inputs, or site specific or exposure scenario specific inputs that we can use in exposure scenarios. Say, okay, well, these are the particular things, and we include those in calculations. And when I'm doing calculations, I explain them out. This is equation 1. This is equation 2. This is equation 3. They build upon each other and show us how we got from one calculation to the next and what those calculations mean. And at the end, we put them all together. That's just the beginning part of explaining how we get through a risk assessment, including, again, what are the inputs? What are the standard inputs, or what inputs are we using in the equation? We also rely on laboratory data. Do we rely on a mean value or an average value? What were the number of samples analyzed to come to that average? Was there a spread? what methods were used in the laboratory? I want to understand what methods. If it's a particular scenario, I say, well, that method may not be applicable to that scenario. What if it's an environmental exposure scenario where it's inhalation, but the particulars are where they're looking at something from an ingestion or oral exposure scenario may not be applicable to that scenario. What is a QA/QC at the laboratory? Well, did they do this under maybe it's of food manufacturing, or maybe it's another type of laboratory internal QA/QC where it was everything in check. I look at that data as well. I show my methods. Do I do a sensitivity analysis? Well, if they said they use the lower end of this is what the dose would be. And if they had used the higher end, 95% upper confidence level or limit, the exposure could have been this, but the average across the entire time they were using it, right in the middle, this is the one. So are they showing a range? Or are they just reporting one data point? What were the safety factors that were built in? Did you have anything for extrapolation? Did you have any safety factors that were built into it? And lastly, did you have any unknowns? All this is explained out in all reports. You can look at a scientific study. This is typically what goes into a scientific study. What were the unknowns? I didn't know this. I had to assume this. Or I didn't know this. I used a surrogate measurement or surrogate source for this for inputting here because I don't have it. Doing the best with the information that we have, because sometimes not all the information is available, but explaining it out. That's where that sensitivity analysis comes in. Here's a problem with the state of Florida data. And again, this data may be out there. This information also, based on my search, I haven't identified it. And maybe it may exist. But here are lots of problems that I see with this and the data gaps that putting it out like this creates. Okay. What methods were used to evaluate the arsenic content? Did they follow FDA methods? For example, FDA has, and this is just a brief discussion of it. They have something that says Elemental Analysis Manual for Food and Related Products. Was that used? Oftentimes, I have seen where, especially for product safety assessments, where people will grab products off the shelf and say, hey, and this is not even a product safety assessment. This is just a shot in the dark kind of scenario, but they'll grab a product and say, hey, let's see what's in this product. And they'll send it into a lab and they don't tell the lab what it's for. They just say, we want to see if this is in there at some amount, going back to the hazard. Is it there? Is a hazard there based on some amount? And they'll do an analysis and they'll come back and maybe their data says, yeah, that thing is in there. But when you get down to it, and again, this comes, particular for the individual or the human health aspect, maybe you get in there and look at the data or look at the laboratory report and say, well, they analyzed this using an extraction methodology that is not mimicking human physiological factors at human physiological temperature. Maybe they did it at 60 degrees centigrade or 100 degrees centigrade. And you're like, that doesn't make sense. Are they doing it because they're trying to get out everything that's in there? Or are they trying to mimic realistic physiological conditions that you may encounter when you're ingesting or in contacting this material? That information is not available from the state of Florida. I can't look at this and say, oh, what did they do? Was this a realistic exposure scenario from a laboratory? The laboratory have QA QC on this data? What were the QA QC? What was the methods? And I do this, and labs probably get annoyed with me, and it is what it is. Probably some people who work at labs saying, yeah, I agree. Spell it out. What did you do? What was the reagent that was used? Was it, if you're doing HPLC, was it HPLC grade? What was the particulars? What was the lot number? I want this to be traceable. I want us to be able to reproduce this. I want somebody who's never done this to be able to look at this. I'll say a laboratory hasn't done this, to look at this and reproduce this and be able to get very similar results to what they're doing. I have no idea what the state of Florida did here. What was the method? How many samples did they run? Is this an average? Usually what I do, and it depends on the scenario, I'd say, okay, let's do a minimum of 3 samples. Probably 5 samples would be better, but maybe it's 3 independent lots, you know? What was the methodology that was used? Did they just grab stuff off the shelf? Which again, they did here, it seems like. I don't know. That's not it. There's no, "Hey, this is the methods that we use. Look at this." You can go grab a journal and look at the process that they use. Introduction, your background, methodology, results, discussion, conclusion. This is not a study. This is just data that's put out there with no meaning. I don't know how many samples they did for the one particular candy here that I'm looking at. It's the first one, second one. Did they just grab it off the shelf? I don't know. There are also some here that say it says arsenic parts per billion and just has a dash. Does that mean there's no arsenic? Or does that mean that it wasn't detected above the reporting limit of the laboratory? What was the reporting limit of the laboratory? Is that giving false indication that there is no arsenic here? Or maybe the reporting limit was so high that the method that they chose couldn't see it when there may be other more sensitive methods. I've got no idea because that data is not here. These are huge data gaps, and this is a complete oversight to release this information in a way that doesn't give the context to it. These are data gaps that scientists will look at it and go, "I don't know what this data means. I have no idea. I want to see the lab report. Give me the lab report." If in fact, if you look at the bottom of the page, and I'm doing it now, it says download the test results. It's just a summary of the test results and the web page in a PDF form. It's useless. These are useless data. Honestly, I can't believe I had thought it was put out like this. Okay, now let's go through a little more. In the beginning, the information presented, it's literally just, I think, 2 sentences here. It says the following shows approximate quote unquote safe consumption amounts per year based on developmental age where arsenic was detected. Again, detected. What was the detection limit? Was it sensitive enough? Why not put lower than blah, blah, blah? I've got no idea what the detection limit is. Arsenic exposure beyond limits that are considered safe can increase the risk of cancers, including lung, skin, kidney, and bladder. Oh boy. Oh boy. So, from a toxicologist standpoint, are we going to ignore potential toxicological outcomes versus carcinogenic or cancer-causing outcomes? Are they at different levels? Yes, there are different levels. One is a chronic exposure, one is acute exposure. Did they only look at chronic exposures here? Did they evaluate acute exposures? I've got no idea. What in their evaluation, what was the developmental age that they're doing? They just have child and adult. Was child a range from 1 to 18 years old? I've looked at NHANES data. We've got data that are being published in results and working on finalizing that data now from NHANES and saying, what are we looking at here? What are the ages? It could be 3, it could be 4, it could be 5. Is it up to 10? I've got no idea what they were considering child in their data and analysis. Sometimes if you look at EPA, it may say up to a certain age. If you look at the FDA, it may say 0 to 2. Are they missing, I'll say, in-betweens? Again, data gaps. That information is not here. It's crazy. Okay. What Going back to the toxicological carcinogenicity outcomes or cancer-causing outcomes, did they evaluate bioavailability? What was the bioavailability they used in their equations? Again, this goes back to when I present risk equations, I say, what is the absorption factor? What is the bioavailability? Is it 100%? Is it 50%? Is it 10%? Based on scientific data. I've got no idea what they use. Maybe they assume 100%, but I don't know that. Doesn't say anything. Did they look at this and say, all right, well, did we speciate the arsenic? Because interestingly, There are data out there that shows, well, again, going back to the organic versus the inorganic form, that when you're looking at total arsenic, inorganic may only make up a small portion of the total arsenic that's there. And maybe a lot of it is the organic form, which is not as toxic. What are we looking at? Did they speciate? Is this total arsenic? I can't look at lab results. Maybe they're out there somewhere. They are not on this webpage that I can identify. I've clicked all over. It's not here. It's almost it's crazy that this data would be put out. This is stuff that you would put out and is just a shot in the dark to try and get someone in trouble. Because I have experience in working with food manufacturers and performing GRAS assessments, I have an understanding of what's required under, I'll say, um, Food Safety Modernization Act, Food Quality Protection Act, that say, listen, if you're doing these analysis, you have to set specifications on your food products. We are, controlling things under a good manufacturing practice. These are our tolerances. They establish tolerances and they are listed. They have certificate of analysis or certificate of authenticity almost, and says, we analyzed this particular ingredient. We didn't find this. It was below our tolerance threshold. Did they approach the manufacturer and say, can we see your COA? We understand what your COA is. We understand what methods you use for your COA to determine your levels. What levels did you get? There's no indication, again, maybe that information's out there, I have no idea, that they approach manufacturers and say, hey, can we compare our data with your data? Or is this just hey, we don't want kids eating stuff. We're going to bias the results to make it seem like it's got a lot of arsenic, but we're not going to give the information for any independent evaluation of it. This is craziness to put this data out here. But you can go look at it yourself. Maybe you have the same questions. Maybe you don't have the same questions. Again, going back to the ones that have non-detect, it says risk not identified. Well, what was the risk? Was the risk not identified because you couldn't or you didn't do the proper methodology? If you look at, and I'm not saying that this is the case because, if you go look at FDA, go look at their information out there and search up food, uh, food and FDA. There's a lot of information that says, okay, well, there are industry information out there for inorganic arsenic in apple juice, inorganic arsenic in cereals for infants and rice, and even bottled water. If you go look at 21 CFR, which is one related to the Food and Drug Administration, on some dyes, there are statements that says, arsenic's not to exceed a certain concentration, 3 parts per billion or something like that, or parts per million. But it's supposed to be low. It's not supposed to be in there. But understanding that it is a naturally occurring element in the earth, it's like, listen, we don't want it in there, but this is the tolerance. We want to, so a lot of times people, manufacturers will see that, be like, we're going to set it even lower. We don't even want to see that in there at all. But I have no idea what the state of Florida did. I have no idea what their risk levels were. I have no idea what their sample sizes were. I have no idea if they compared them. There are reference doses out there from EPA IRIS. If you're familiar with EPA IRIS, if you're familiar with ATSDR's minimal risk levels, EPA IRIS is Integrated Risk Information System. We have reference doses and reference concentration, ATSDR MRLs. There are safety thresholds that are established. Did they compare these to any safety thresholds? Or are they just putting this out there? How do they determine this risk level? What are the calculations that they use? What are the input variables that they use? Was this a lifetime exposure for children or adults? Was this, because if you're talking about cancer, you're going to have to talk about lifetime exposure. And is this safe consumption level based on carcinogenic outcomes? Or is it based on toxicological outcomes? Nobody knows. Maybe somebody does, but it's not out there. So when these are things that I want to express when I am doing assessments. This is what we do all day, every day. But I'm very transparent about the methodology. This is what we do. I lay it all out. This is how we come to it. There's a scientific rigor that goes into this. When I have people calling up and say, well, what does this mean? I've got no idea. I've got no clue what any of these do. I am inviting anyone from the state of Florida, the Florida Surgeon General. I'm happy to have them come on here and have a discussion on the podcast about this, or anyone who is involved in performing these risk assessment calculations or identifying risk or understanding it. What were your methodologies? What were your assumptions? What were your input variables? Put that information out there. Put the laboratory data out there. Put the methods that you follow out there. Come on here, have a conversation. I'm happy to have you on. I'd like to understand it because it does. Many times it makes my job harder when I have to try to explain risk for something that I can't determine what the risk was. And someone would be like, well, what does this mean? Am I more of an increased risk? I've got no idea what this means. So do I need to go back to my information to look at data and do all these scientific evaluations and say, well, these are the data that I have that's published in peer review literature that say these are the amounts, perform the risk calculations, show you how I got there and say my risk is not equal to theirs. And I haven't done those calculations. I don't know if they are or not, but I have no idea how they got to theirs. Again, this is food for thought for you. When you see information out there and it's an attention-grabbing data point, you say, oh my God, what does this mean? Think about it in context. Look at it and say, okay, put your exposure scientist cap on, or toxicologist cap on. Go, all right, if I see something that says 480 parts per billion of arsenic, and a child can have 4 pieces of this per year at a safe level. What does that mean? I have no idea. Should you want to know what that means? Definitely. You should definitely want to know what that means. Make the data available. Question this data. Say, well, this is one of the scenarios that I tell people is just trust me, bro scenario. No, no, give me the information so I can independently evaluate it. What I always tell clients is, sure, that sounds great. That information, that safety information they're providing you sounds wonderful. Let's independently verify. Let's have a third-party oversight done. But let's be transparent about it. Maybe this is the attempt by the state of Florida to have some kind of third-party oversight. But again, I don't know what they're doing. I don't know the transparency of it. So when you see data that's like this, that's not an EPA study, if you want to go look at EPA or FDA studies, they're long. Their methodologies explain, they reference studies, they evaluate risk. They tell you what's going on. That's a better idea and understanding than just seeing a data point here saying, well, I don't know what that is. And this goes beyond the state of Florida. This goes for anywhere who's just giving you data and say, look at the scary number. What does that scary number mean? What does toxic mean? What does harmful mean? What does hazard mean? What does risk mean? I want you to think. If anyone from the state of Florida wants to have a conversation with me about this, I'm happy to, because this is not helpful. This just creates muddier water for us going forward. If you want to put all the information out there, great, let's do it. But if you're gonna gatekeep the information and keep it from us, I don't know what to tell you about this. It is useless data as I see it. Data that is not interpretable for evaluating hazard and risk and exposure. Again, this is hopefully to make you think, hopefully to make you question some things and want to know more information. Say, give me more information. Give me the data. Give me the information so you can independently look at it. Again, anyone from the state of Florida wants to reach out and have a conversation, please feel free to come on the podcast. If any seasoned listeners or new listeners have any questions, want comments, please feel free, reach out, email, call. I'm out there. I hope you learned something on this podcast. I hope it gave you an idea to think and ponder and want more answers. Hope everyone is doing well in the new year, and I look forward to talking with you in the next episode. Thank you so much. Exposure science covers a broad subject area, including toxicology, industrial hygiene, and risk assessment. From occupational, community, or environmental exposure scientists apply scientific methodologies to understand exposure risks and apply controls when necessary. We at Exposure Assessment Consulting have this expertise. Please reach out to us at info@exposureconsulting.com for a free 15-minute consultation to discuss the specifics of your exposure scenario.